All right, let's talk about Postgres. When you start out with a SaaS, it's easy to worry that you're going to have this problem with the database where you have too many customers, too much data. You can't keep it all on one server, and you're going to have to scale out. You're going to have this big, complicated multi server architecture. You're going to have to do some kind of sharding or something like that. It all sounds really cool. People write really interesting blog posts about the stuff they did to scale. But the reality is that Postgres on one single database server can scale a lot further than you think. It scaled a lot further than I thought it would. I'm going to open by telling you a story. I started out at this scrappy little SaaS startup about 13 years ago, and we were running on Postgres. We didn't have that many customers yet, but to me it seemed like a lot. Probably had a couple of hundred. And there were some reports in the system that were running really slow. And I went to the guy who was the senior engineer. I was still pretty wet behind the ears in my 20s. And I said to him, "Oh, do we need to start looking at, maybe sharding the database and doing some kind of exotic things like that, and maybe moving customers to different regions and having separate servers for different people and this sort of thing?" And he shook his head and looked at me like, "What are you talking about? You're not going to need any of that. We don't need any of that. Give me 5 minutes." He went through the query for the report we were looking at. It was one big SQL query. He went through it, and in about 5 minutes, he worked out which join was causing a sequential scan in Postgres, fixed that, put an index in, and the whole thing ran incredibly quick again. That was a learning experience for me to realize just how quick the database can be. It's very well optimized for retrieving data from a very large data set. You are probably not going to need anything fancy. One big Postgres server is probably going to take you as far as you ever need to go before selling. You're only going to need to worry about sharding when you're getting to properly big scale into Lambo territory. Don't worry about it until it's really, really pressing on you. Now, there's a few reasons that that is the right advice. So the first one is that complicated solutions have complicated problems. One of the best pieces of advice I ever got when I was a junior dev. Don't overcomplicate the solution. Start with the simplest thing that might possibly work. Why? Because if you use a more complicated solution, even though you think it's maybe more robust, complicated solutions tend to have complicated problems. Vive la chose simple. Long live the simple things. Simple things don't break down. They don't have so many moving parts. They're easy to fix. When you have something with lots of moving parts, there's lots of different ways it can go wrong. Now, a missing index in the database is a lot easier to diagnose if you know what you're doing, and a lot quicker to fix than an inter-process race condition between microservices. That is way harder to track down, way more time consuming, harder to replicate. A missing index in the database is an oopsie that you can fix in 5 minutes if you know how to do explain, analyze, and read the output. And probably the coding agents will probably do that for you now anyway. Okay, so keep it simple. That's the first thing. Second thing, hardware is a lot cheaper than more engineers. If you need to, you can bump up the memory on your DB server for another $100 a month, $500 a month, maybe, if you're getting really in the high end. What's a dedicated DevOps engineer going to cost you? If you've got to hire even one extra person to handle the complexity of your system, to handle building because of the complexity, that's going to completely blow any budget you had for a database server out of the water. At a minimum, even if you hire someone sketchy from some third world outsourcing place, you're going to be paying in the tens of thousands, right? You're going to be paying thousands of dollars a month. Hardware, a bigger database server is just much, much, much cheaper. That's simple dollars and cents. The final thing is that, remember we talked about your data is an asset. The code, backend and front end, is a liability you have to maintain, but the data in the database is an asset. It gives you insights into how your customers are using the system, which then tells you what you want to sell them next. It tells you who are your best customers, who is the avatar that you want to go after to find more customers who have the highest lifetime value. All those kind of things are in your database. So you want to have there be one source of truth. You don't want to be confused about the answer to your questions. You want to be able to have your people write queries, generate reports from the data in your system, and know that the answer that comes out is the one true answer. It isn't one of 5 possible answers from different parts of the system, different snapshots. You don't want to have multiple data sources that have to sync with each other and might get out of sync. Then you get bugs that are really hard to track down. You want to keep your system easy to monitor. As soon as there's more than one database, more than one source of truth, now you have to worry about timing. You have to worry about, did this event occur before or after that event that was happening on another system. It's really hard to take a snapshot of the sequence of things that happened in order to reproduce a problem. You keep it easy to monitor by having one source of truth. Having one database lets you deal with concurrency at the application layer because that single database can direct traffic and handle things like locks. On top of that, even if you have perfect engineers who never create any bugs, it will still be more difficult, it will take them longer, it will be more expensive to build features, not to fix bugs, but just to build new features on top of a complicated foundation. Again, the principle always is keep it simple. That is especially true at the database layer. Don't worry about scaling. You don't have to worry about it until it presses itself upon you. And that's not going to be for a long, long time. You're probably not going to have to worry about this until you have in excess of 10,000 customers. I have seen a SaaS run more than 20,000 customers actively using the system on one big Postgres server. It's totally doable. It's not a problem. Now, you got to remember that you have time. Don't panic about scale. You have time to sort it out. At the point where scaling the database layer will actually be a problem you have to solve, first of all, that means you've got too many customers. That's an excellent problem to have. But the side effect of having too many customers is that you will have money available. When you get to the point where scaling the database layer is the pressing problem, you will have cash, and then you will have options on how to solve it. You can hire the right people, you can get consultants in, you can pay a team to come up with a plan for how you're going to migrate to a new system. There's ways to solve it, but they're heaps easier to execute on if you already have money. And you'll have money when this problem actually occurs, because the reason it occurs is that you have too many customers. All that to say, one Postgres database. Don't make it more complicated than that until you are absolutely positively forced to do so. Assume there is a way to solve your scaling problems without complicating the stack. It is probably as simple as a missing index. 99 times out of 100, there is a way to optimize the query without changing the architecture. Keep that in mind. I'll see you on the next video.